Hello, algebra class. We're going to try to do things a little bit differently today and this week, and we'll see how it goes. We're going to start a new section right now about systems of equations. Right, the last thing that we did was just solve like equations, one equation with one variable, one x. The next step is to solve what we call a system of equations, where there are, instead of just one equation with one x, there's two equations with two different variables, like an x and a y, or maybe it's an a and a b, or anything else. Like if there's two equations that have two kind of unknowns, we can actually solve these, right, and kind of figure out like where the two things are the same. So we're going to look at a few different examples. I'll try to probably make them be different videos each. But we're going to just start with this very kind of first example, this race example. So it says Leighton and his dad are running a race. Leighton can run 4.5 meters per second, and his dad can run 7 meters per second. They're running a 100-meter dash, and Leighton's dad gives him a 40-meter head start. So who wins? So we need to define our variables. So we'll let x be the time measured from when the dad started. So Leighton's getting a head start, so that means that he's going to have this like 40-meter head start. So when the time is 0, y is the distance from the starting line. When the time is 0, Leighton is already at 40 meters, right? Put in 0 for x, that's going to go away. And the dad is just starting out, right? This is his speed times the number of seconds. So after 1 second, he's been 7 meters. After 2 seconds, he's gone 14 meters, etc. Right? And so we want to find out, right, who's going to win this race. And what we really need to do is figure out where the dad is going to catch Leighton, right? Where they're at the same place, x, at the same time, y. And so we're going to do this two different ways. First, we're going to do it algebraically. So we're going to do that just in Desmos. Right? We have our two different equations. The dad's is y equals 7x, and the kid's is y equals, I think it's 4.5x plus 40. Right? If I graph this, they're going totally off of the screen, so I need to change my axes. So I'm going to pinch the y-axis here so that it kind of shows what's going on, and then same thing with the x-axis. You can do the standard zoom in and out, but it's not really going to work super well. So the red, this is the dad, right? He's starting at 0, 0, right? At 0 seconds he takes off. The kid is at 40 meters already, and we're trying to figure out, right, where they meet. Where are they at the same place on the y-axis, right? This is my distance at the same time in my x-axis, right? And so to do that, we want to figure out where these guys intersect, right? They cross here at this point, right? This point at 16, 112. Again, always x, y. My x is 16. My y value is 112. Right? I'm going to come back here, and I'm going to take a little screenshot of that, right? Just so that we kind of have the graphical representation here in the notes, right? So graphically speaking, here's my, let's shrink this up a little. Yeah, I don't want to condense it too much, but right. Graphically speaking, here's my solution to this, right? We said x is the time and y is the distance, and they're at the same distance, 112 meters, right? This is the distance in meters. At the same time, 16 seconds, right? So what this is telling me is that it took the dad 16 seconds to catch up to his kid, right? The kid got a head start, was running. The dad took off after he was already at 40 meters, right? But didn't catch him for 16 seconds and at 112 meters. But the race finished at 100 meters, right? Like here's my race being finished. And so I could find that, right, if I wanted to kind of take a look. I know that the kid's going to win this race because the dad was behind the whole time, right? Was further down on that y-axis the entire time until after they hit 100 meters, right? So the kid wins this race. If I wanted to find out exactly where they each were when they hit 100, I could put in this, right? The kid took 13 seconds from when the dad left. It was 13 and a third seconds later. The dad didn't cross until a little bit after 14 seconds. So the kid won that race. Right? But what we're really interested in is this solution, right? The solution to the system of equations, right? That it took the dad 16 seconds to get to him 112 meters later. So my solution to the system, this is what we call this. The solution is 16, 112. So x equals 16 seconds. And the y is 112 meters. And so I know since the dad was behind the whole time, the kid won the race. What we're really going to focus on, though, is the algebra. How would I do this thing algebraically? How would I take this, slide it over here, and do it without a graph? Right? That's what we're really trying to practice. So we want to find out when the x and the y are the same. And so I have these two equations. The y equals 7x and y equals 4.5x plus 40. And I want these two things to be equal to each other. I want the y values to be the same. So what we're going to do is something called substitution, where substitution says, I know that y and 7x are identical to each other. So what I'm going to do is replace the y in the second equation with this 7x. 7x and y are the same. So if they're the same in the top equation, let's make them the same in the bottom equation. So that becomes 7x then. I'm replacing the y with 7x equals 4.5x plus 40. I'm just going to do a little substitution there. Replace this y in the second equation with what y is equal to in this top equation. And now I'm back to what we did last week, solving a single equation, right, with one variable. So I have this equation. Let's try to solve it. If 7x equals 4.5x plus 40, I need to move this 4.5x to the other side. We're going to use that subtraction property of equality to subtract 4.5x from both sides of this equal sign. Right. I should say, right, this is my new thing that I'm adding on to both sides. I'm subtracting 4.5x from both sides. Right. And that's going to make this go to 0. It disappears. Something minus itself is 0. 7 minus 4.5 is 2.5. So I have 2.5x equals 40. And then I'd have to divide both sides by 2.5 to get the x by itself. Right. So x equals 40 divided by 2.5. Let's go to Desmos and see what is 40 divided by 2.5. It is 16. Right. So I got my x equals 16, the same 16 that we found graphically here. This is half of the solution to the system of equations. Right. I also need, I need to find what the y coordinate is. So to find the y value, right, I have this, right? The time is 16 seconds. That's how long it takes. But I need to find the other half, the y value. So to do that, we need to plug the 16 back into one of the original equations, right? Plug 16 in for x in one of the equations above. So we had y equals 7x was one of them. That's the easiest one, I think. So let's just put in the 16 for x there. We'll get y equals 7 times 16. Again, go to Desmos. Right. What is 7 times 16? It is 112. The same solution we got up there, right? Once I have my x's and my y's, I can say the solution is x equals 16, and y equals 112, or it's the point 16 comma 112. And that is the basics of solving systems of equations. An example using a pretty simple substitution method will get a little bit more complicated in the next videos.